Hey everyone, it's Isaac from the Flutter Markup Language dev team. Today we are going to go over connecting to data sources, traversing their structure using data binding, and manipulating their data using TRANSFORM Widgets within your Flutter Markup Language app. No back-end work required. If you are unfamiliar with the basics of FML, you can check out some of our other videos, or visit the wiki on GitHub for in-depth information. The list of data sources, both hardware and network-based, that FML can connect to is quite extensive, with endless possibility for traversing and manipulating data. Today, we are going to cover one of the Rest API widgets, GET. To get started, you will need an FML environment up and running and the FML engine on each of your devices you plan to use for testing. If you do not have this set up, you can check out the links in the description to do this locally, over LAN with XAMPP, or online using ngrok. If you have file server knowledge, you can also set this up in any environment you would like using the server.zip file download from fml.dev. As you can see, I am running FML as a web app in Chrome, as a Windows app, and as an installed Android application. For the data today, we are going to use the free API randomuser.me/API, which returns a list of random users in JSON format. Remember, FML supports both JSON and XML formats, so the tutorial will be the same for both styles. If we format the call, you can see the data structure consists of two outer elements, results and info. Each of these have nested inner elements. This call returns a JSON body. We can then manipulate the number of results by appending results equals and providing a number of results we would like to the URL. As you can see, we now have 4 results. Let's get started incorporating this into our FML app. First, we will go to the base folder on the sample app called templates. We are going to use main.xml to navigate to our test page for now. Let's restructure the button that takes us to the counter app and point it to our new page. Let's call it get_example.xml and pass that to the open event. Rename the label on the button and save it. Now, let's create a file called get_example.xml in our templates folder and open it using VS Code. Let's get started on using the GET widget. First, we create FML tags and give the template a version and title. Next, let's create our GET widget. The widget will make a GET call to our API endpoint. We give it an ID, let's call it user data, and the URL of our endpoint. The GET widget will automatically start the GET call when the page opens. Now, let's display some of the data on our page. First, create a column and put it in the center to display some text. We are going to give the text a data binding of the ID of the GET dot the attribute we want to display. In this case, it will be userdata.url. We surround this with curly braces to denote it is a binding. Navigate back to our page and we can see the URL our GET widget is calling. Next, let's bind to the data it is returning. As you can see, the results and info elements are on the outer level of the JSON, so let's display those. To bind to the results, we need the data attribute of the GET widget, and we can call this using id.data.element. In this case, userdata.data.results and userdata.data.info, again in curly braces to denote that it is a binding. On returning to our page, we can see our 3 bindings. This data isn't very useful to the user, so let's display specific values within the results. Looking at our data, let's access the gender tag under results. Now, we only want data from the results rather than the info. So we can pass root equals results to the GET widget, telling it where to start. Let's create another text and display userdata.data.gender. As you can see, the gender is displayed from the data set and the call is made automatically on starting the template. Now let's try accessing a deeper element. Traversing the data, let's display the name of the street. To do this, we need to see the structure of the data, which is results, then location, then street, then name. Since results is our root, we can omit that, create a text widget, and bind to this data using userdata.data.location.street.name. Now we can see the street names displayed. Next, let's take a look at accessing multiple repeated elements within the data. Let's add the results equals 4 parameter on the URL, which will return 4 results. To access repeated elements without the use of a data UI widget, you can simply use the index notation on whichever element is repeated. In this case, results is repeated, which is our root, so we can use data:3. This gets the third index of results and would be the same as using data.results:3 if our root was not results. This can be added to any element down the dot notation, and supplying no index is the same as saying :0 on each element. Now, as you can see, we have both the 0th and the third index street names displayed. To make better use of this, let's look at automatically displaying repeated elements using the data UI widget list. List takes an item, and that item acts as a prototype for each repeated element at the root of your GET call. First, we create a list and an item. Next, we pass the list the data source we want to repeat. In this case, the data is user data. Now, when binding within a list, we do not need to use the ID. Because the data is passed into our list, we simply use data dot instead of id.data dot. In this case, data.gender and data.location.street.name. Let's switch the column to a box and give it a border and some border attributes so we can see the outline of each element. Now we see the list and their respective bindings created. With GET widgets, we can create bindings within the URL to automatically refire the GET whenever the URL changes. To demonstrate this, let's create a slider. We give the slider an ID of result num, a value of 4, and add its range attributes to be from 1 to 8. To update the result number and automatically rebuild the list, we simply bind to result number within the URL. Remember, binding to a widget's ID without an attribute always returns the value. Now we see that our list automatically rebuilds and reflects the number we have chosen. If we do not want the GET widget to fire automatically on the start of the template or on change of the URL, we simply set auto execute to false and call the GET using id.start. Finally, let's take a look at transforming data from within the application. This is useful if you do not have access to the backend or if the backend cannot be easily updated for individual use cases. Transforms can be compounded and nested within data widgets to allow for greater control of data sources and their binding. First, we will open up the GET widget to give it a transform. Let's show only male users. To do this, we will choose the filter data source. Give it a filter equals attribute and bind to data.gender, which is the parent's data, equals male. Whenever the filter value is true on the repeated element, it will retain it in the new filtered list. As we can see, we now only see male users returned. Next, let's add a second transform after filter. For this case, let's take the oldest male in the list and insert his age within each record. Transforms take effect in the order they are listed, so the second transform will only affect the filter data. Let's create a calc and give it a target of dob.maxage. This is the field that will be inserted to hold our value. We give it an operation of max to find the record with the maximum, and the target of this will be dob.age. This means the calc will find the max age in all of the results from the filtered data and apply it under a new field called max age in every result. Now we will see this is applied and the max age of only the displayed males is shown. Let's make this a little more useful by showing a difference. We can do this with a transform as well, but in this case, let's do it within the template to demonstrate the ability to display any data. We create a text to display the value. Next, we create a var within the scope of the list item to display the value. We give it an ID of difference and a value of equals, which signifies we're about to perform an evaluation. Data.dob.maxAge minus data.dob.age. We pass the binding into the text, and as you can see, we are able to display the difference within the list item. We can also nest and bind to different subsets of data using the data widget. If we wrap the two transforms in data, give the data an ID of filtered data and a URL of the parent's ID, you can see as we pass from the outer data to the list, it is now unfiltered. If we switch the ID to the inner data element, it is now filtered. And that's it for the overview. As you can see, at its most basic level, FML makes binding to and manipulating data from any source in any structure simple. To check out binding to hardware data sources such as NFC, camera, file picker, and more, and using detector widgets to bind to information such as barcodes and OCR data within images, you can keep a lookout for the next article on hardware data source binding. If you would like to learn more about building your app, data sources, transforms, and more in Flutter Markup Language, you can visit the wiki where we have examples and documentation. For any questions or feedback, or if you would like to let us know what to do next, please comment or join our Discord. The link is in the description. Don't forget to like and subscribe to stay up to date as we roll out more content to help you build cross-platform applications using Flutter Markup Language. Thanks for watching.